Okay, now we are into limits from algebraic formulas. This you will recognize as a rational function. It's one of the things that we've dealt with early on in the year. You may have forgotten a piece of it, so stay tuned for like a quick review. But the question that is being asked right now is actually like, do you understand this limit altogether? Do you understand the limit of g of x as x approaches negative 4? It's a really cool question because if you look at this function, you will notice right away that we have a matching factor in the numerator and the denominator. And if you will recall from our rational functions unit, that means that this function has a hole in it right there. If you plugged in negative 4, you would get 0 times something over 0 times something, and that means the whole function is going to evaluate to undefined. Like 0 over 0 cannot exist. You cannot divide things by 0, even other zeros. But the pattern that you all spotted for me, and I like remember Taiwan pointing out like it should be something, it just isn't, was actually like a fundamental understanding of limits. He was noticing that like the pattern around it governs that it should be approaching this one thing, but for some weird reason the algebra evaluates differently at this one place. So the solution that you all came up with was, okay, so you can take this part that is throwing all of our data off and you can cancel it. It's a matching factor. Like that's an old algebraic idea that we have. So that means that g of x like could also be thought of as x minus 2 over x minus 12 with a hole at x equals negative 4. And then this becomes a lot easier to evaluate. And not only that, but like now it is defined for negative 4. So even though we know that the actual value, g of negative 4, we know that it does not exist because there was a hole. But now we can talk about what the hole should have been. And this is cool because so far the only way that you've had to talk about that is to like give coordinates of a hole, which doesn't really make sense. It's like impossible to say where something isn't. But with limits, you can say what it should have been. And so plugging in this negative 4 to like our simplified version, the one that doesn't have a hole, we would get negative 4 minus 2 over negative 4 minus 12, which should come out to negative 6 over negative 16. Negative divided by a negative is positive, so I can just rewrite that as 6 over 16, and then both of these are even, so I can simplify that to 3/13, which means that the limit of g of x as x approaches negative 4 is 3/13. And if you want to Desmos this and prove it, you absolutely should, but what you'll find is that we're getting closer and closer to the number 3/13, whatever that is in decimal equivalent. You'll have to calculate that. But then once you actually like get to the negative 4, it doesn't exist. Very cool.